What is a semiconductor? Describe the two main types of semiconductors and contrast their conduction mechanisms. Now, this is a very fundamental question and a very important one. What exactly is a semiconductor? We know what are conductors. Conductors are the ones which conduct electricity, right? And what are insulators? Insulators are the ones which do not conduct electricity. Conductors have very high conductance and insulators have very, very poor conductance naturally. If we are talking about semiconductors, semiconductors are the substances which have conductivity not as high as conductors, but again not as poor as insulators. They are somewhere in between. Okay, so the conductors, whose conductance lies between those of metals or good conductors and insulators, they are termed as semiconductors, right? Is there a quantification? Can we have numbers associated? Yes. You can say that if their conductivity lies between the range of 10 is to minus 6 to 10 is to 4, there is a difference in order of 10 is to 10, which is pretty substantial. But if this is the range in which their conductivity lies, then this range is called, this is the range of conductance, and then they would be called as semiconductors. Fine. Typically, if you have insulators and if you heat them, they will just be insulators. They would not start conducting electricity. If you have good conductors like copper wire, silver wire, aluminum wire, if you raise the temperature, their conductivity decreases, resistance increases. Semiconductors are very interesting in the sense that their conductivity increases with rise in temperature, because if you raise the temperature, more and more electrons now have energy and they can jump to conduction band and they can conduct electricity much better. So a very good point of difference between semiconductors and regular conductors is that regular conductors decrease their conductance on increasing temperature, and for semiconductors it is the opposite. Well, if you talk about types, there are two types of semiconductors, N-type and P-type. What is N-type? Just imagine that you have a crystal of silicon. Fine. Now, silicon or germanium, typically they are the ones which belong to carbon family. They are nice, lovely, complacent substances who are just sitting. They don't conduct electricity as such. But in a crystal of silicon or germanium, and let me remind you, silicon and germanium, they have diamond-like structure, extensive covalent network of tetrahedra. In that, if you insert an atom of arsenic or phosphorus or anything of group 5, it also could be antimony. Now imagine that you have giant crystal network of silicon. And amongst them, there is one atom which is not silicon but phosphorus. Now, silicon had 4 valence electrons, phosphorus has 5. So 4 of them will be used for making bonds just like silicon was making 4 bonds. But phosphorus or arsenic atom or antimony atom, now they have 1 extra electron. And 4 out of 5, they are used in forming covalent bonds. And the 5th electron, since it is useless. And please note, phosphorus or arsenic atoms also want to hide and they want to camouflage. They just want to behave as if they are silicon, because everywhere it is silicon, 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 silicon. But they also want to behave as if they are silicon. So they just say, you electron, you go away. So they just push away that electron extra so that they can blend in, and they can blend in and they can just stay happily in that crystal. These electrons start drifting within the crystal. And these are the ones which give rise to conductance. And since these are very few electrons, it does not become a good conductor, it becomes a semiconductor. Pure silicon or pure germanium is an insulator. And silicon or germanium which have been doped with means which have very small quantities of phosphorus or arsenic or antimony, such group 5 elements sitting with them, mixed with them at certain locations, they would be termed as N-types. N is negative, N comes from negative because you have an extra electron, so they are N-type semiconductors. They are electron rich, and because these extra electrons are drifting from one place to the other, you get conductance. This is one mechanism or method of conductance by a semiconductor. Is there another type? Yes. Same crystal of silicon or germanium. Now, instead of group 15, try mixing an impurity of group 13. Try adding a little tiny bit of boron. And this is in ppm quantity, not very high. Say you have boron or aluminium for that matter. Oh my God, what would happen? Now, boron or aluminium, instead of 4, they have only 3 valence electrons. If they have only 3 valence electrons, they'll just form 3 bonds. But we wanted a 4th bond, and there is no 4th bond. Why? They don't have electrons. So there is a gap, there is a hole. Yes, there is, you can say, an electron hole or electron gap. And this electron hole or electron gap would tend to, attract electron from a neighbor. How exactly? I'll draw a structure and I'll tell you. Say it's like this. If you have, say, we will just use the other page. There's a very good diagram also. See, if you have silicon sitting everywhere, and suddenly you have a boron. Now silicon had, well, 1, 2, 3, 4 valence electrons, right? And since the neighbor also has 1, 2, 3, 4 electrons, when they form a bond, this has 2 electrons. When 1, 2, 3, 4, they form a bond, this is good. 1, 2, 3, 4. This is a bond. Fine. What about boron? Well, boron has, you can say, I'll just change the color so that you could discover the electrons of boron separately. You have 1, you have 2, and you have 3. That's it. Yeah, that's it. You have just 3. Yeah, I'll take this. Just one moment. Fine. So red ones are the electrons of silicon. The green ones are electrons of boron. You have a bond. Yes. 1, 2, 3, 4. You have a bond here. 1, 2, whatever. So you have a bond here. Fine. But do you see that there is no bond here? Why? Because bond required 2 electrons, and 1 electron was contributed by the silicon, 1, 2, 3, 4. But the boron has contributed nothing. So shameless, very shameless. This is an electron hole. There is no full bond, but it can always attract electrons from here. So if 1 electron jumps, well, a new hole is created here and this hole gets filled. But the moment there is a hole here, 1 more electron can jump from here. So electron can jump from tump like this. Because there is a hole and it's in this electron hole, the neighboring electrons can jump. There is a space, there is a motivation. So electrons can still flow, electrons can still jump. Although they are being borrowed from neighbors, but this one jumps here, this jumps here, this jumps here, this jumps here, ding, 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 they keep on jumping. Again, people will say, oh my God, electrons are flowing. Yes, and they do flow. And if they're flowing, we say there is a current, it becomes a conductor. And yes, this is called a p-type conductor. Why a p-type? P for positive. Why? Because there is lack of electrons, there is 1 electron missing. So my dears, you have n-type and p-type, like this is, sometimes they're called holes, sometimes they're electron holes or vacancies, whatever, and these are p-type semiconductors. When are they created? When group 14 elements get doped with, doping means introducing very small quantities of group 13 elements. Carbon family is inserted with very small quantities of boron family elements, then you get p-types. N-type and p-type, these are 2 types of semiconductors, my dears.